All right, we're going through our practice test for the functions and graphs topic. Just before we get started, you want to make sure that you've got a graphics calculator, that you've got your A4 page of handwritten notes, or in other words, your cheat sheet, and you've also got the formula sheet. So the formula sheet should look something like that. All right, now one thing to mention is what we're being marked on. So you've got the first one is, do you know what you're talking about? This third one here is using mathematical models. This next one's about drawing conclusions and whether you understand how reasonable those conclusions actually are in the real world. And then the very last one is conjectures. So there'll be 2 conjectures in this practice test, just to give you 2 goes at it. Now, do note that the final marks are 62 and the test itself is 75 minutes. In general, you should aim for 70 seconds per mark. Or roughly a mark a minute. All right, so first question here, we got to categorize these. Linear means, is it a straight line? So that would be yes, yes, and no. Directly proportional means that it is both linear and it goes through the center point on the graph, the origin. So first of all, this one here over here cannot be directly proportional because it wasn't linear. This one actually is because it goes through the center point. And this one is not because it doesn't go through the center point. Last, we've got are they functions? And to be a function, you've got to pass the vertical line test. So that one does because the vertical lines will only cut through it once. So will this one. This one fails because the vertical lines will cut through it twice in some spots. All right, next we've got a conjecture. So this is adding up these n odd numbers. So the next one would be 16 when you add it up. And I would actually encourage you to use your calculator to do these sums. You get 25, 36, and 49. Now, to spot conjectures, I'm going to recommend that you have some common sequences of numbers on your cheat sheet. So maybe you'd have all the square numbers like 1, 4, 9, 16, 25, for example. Maybe you'd also have your powers of 2. 2 to the n would be 2, 4, 8, 16, and etc. So put some of those common sequences of numbers to spot it. These ones are the square numbers. So the sum of the first odd numbers is n squared. So for example, 7 squared gives you 49. And when we make a conjecture, we're always looking for something called an explicit formula rather than a recursive formula. So you can't just tell me how do you get from one to the next. You have to be able to say, let's suppose that I was adding together the first 10, I'd do 10 squared to figure out what the sum is. So you have to be able to jump to any n value with your formula. All right, test your conjecture by adding together the first 8 odd numbers. So that would be 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15. That is going to give you, and you can work it out, 64, which is 8 squared. So conjecture is supported. We're very happy about that. All right, find the midpoint of these 2 points. There are 2 ways to do it. One way you can use the formula, and that's just on your formula sheet here. So that's going to be x1 and x2. You essentially just take the average of those, and y1 and y2 taking the average of those. What you're going to get is 2 plus 4 all over 2. And 1 plus 2 all over 2. So we get 6 over 2, which is 3, and 3 over 2, which is 1.5. That's one way to do it. The other way to do it is just think, what's halfway between 2 and 4? It's 3. What's halfway between 1 and 2? It's 1.5. So there are sort of 2 ways to approach this. Find the distance. So we need to use the distance formula here. So distance is going to be the square root of x2 take x1 squared and y2 take y1 squared, just like that. So that actually comes off your formula sheet there as well. This, if we label the points, is x1 and y1 and x2 and y2. So let's calculate this distance. It's going to be 4 take 2 squared, and then it's going to be 2 take 1 squared, which is going to give us 2 squared plus 1 squared, which is going to give us root 5 units. Now I'm happy if you do want to leave it there at an exact answer, but if you want an approximate, what you can do is type root 5 into your calculator and hit this S to D button, and that'll give you the approximate. So 2.24. Now, one thing that I'm going to be really specific about is your end of year Year 12 exam usually asks for 3 significant figures. So that's what we're going to do as a standard. By 3 significant figures, I mean, here are the 3 significant figures, 1, 2, 3, those 3. So that's where you basically cut your rounding off. If you had a number like 12.812 or something, and I wanted to round that to 3 significant figures, it would be 12.8 because it's 1, 2, 3. All right, find the slope of the line connecting the 2 points. So this slope has a formula as well. It is y2 take y1 over x2 take x1. So our y values were 2 and 1. And then the x values were 4 and 2. So you get 1 over 2 for the slope. All right, hence find the equation of the line connecting these 2 points. So pretty much we need to start with y equals mx plus c. So y is a half x plus c because we know what the m value is. We can sub in any point we want. So I'm going to sub in 2, 1. So 2, 1. So y will become 1 and x will become 2. Then we can work out what the c value is from there. So that's a half times 2 plus c. So 1 is a half of 2 is 1. So c is actually 0 in this case. So y is half x plus 0, or in other words, y is half x, just like that. And if you actually look at these 2 points, you'll notice that the y value is always half of the x value, so that works. All right, find the x-intercept of your line algebraically. So y is half x. Therefore, now to find this algebraically, what we need to do is set, for an x-intercept, we need to set y equal to 0. So 0 is half x. Therefore, if we times both sides by 2, you get x is 0 times 2, or in other words, x is 0. So the x-intercept happens to be 0 as well. Now, it won't always be the case, but sometimes it does. All right. Suppose it takes 60 minutes for one person to mow the lawn and 30 minutes for 2 working together. The 3 people each take a third, therefore a third of the total 1 person time. So basically 60 split into 3 people is 20 minutes each. All right, we can complete this table. So essentially, if we split 60 into 4, that's going to give us 15. And if we split 60 into 5, that's going to give us 12. And the way that you can just verify that for yourself is just doing the divisions on your calculator. And there it is. Are they inversely proportional? Well, basically what we have to do is we have to times and then figure out what we get. So we get 60 for there, 60 for there, 60 for there, 60 for there, and 60 for there by doing... essentially what we're doing is n times t. So the answer here is yes. And that is because n times t always gives 60 based on the table above. So the point is it always gives a consistent number, which is 60. Now, if you have something being inversely proportional, you can get the equation quite easily. So pretty much, well, what we learned was n times t is 60, but usually we want it as like t equals. So t can be 60 over n. And that makes sense because the time was 60 split into the n different people. Sketch a graph of t along the axis alongside. So this will be t here and n here. So what we've got to do is graph 60 over n. And basically, I'll show you 2 strategies for this. So one strategy is you want to get the graph here and then just graph 60 over, we'll have to use x in the calculator rather than n, just because there's no real n button for graphing. There it is. And let's just get the top right half of this. So for our window, I want to start at 0 and I might go up to 20, for example. For our y, I'm going to start at 0 and let's go up to, well, actually, t was going as high as 60, so let's go even up to 80 there and see what we get. There we go, a lovely hyperbolic graph. So basically what I do is I go trace and then 1, and then at 1, y is 60. So I know that I've got to have my graph go out quite a bit. So what I might do is make this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You don't need to label every number, like you can skip a few. For example, if I do this, I might go 20, 40, 60. You don't have to label every single interval. All right, we knew that at 1 it was 60. We also knew that at 2 it was 30, and at 3 it was 20, and at 4 it was 15, and then at 5 it was 12. So we're following this sort of shape. If you want to get any point, you can go shift trace and go 5, and you'll get 12, for example. For example, if I go trace at 6, I should get 10 as the y value, which would be my next point across that I need drawing. Anyway, so draw arrows. Connect up your dots to make a lovely hyperbolic function. And then we need to label it with the equation, t equals 60 over n. So that's everything you need for the marks there. Is t a function of n? Yes. It passes the vertical line test. So that's what it needs to happen to be a function. Vertical line test. Wonderful. All right, using our equation, we want to calculate how quickly it would take 200 people to mow the lawn. So we saw before that t was 60 over n. So that means that if you want to use function notation as well, you could write t of n is 60 over n and then work out t of 200. Or you can just do it normally. So you can just go t is 60 over n and then go at n equals 200. T is 60 over 200. Therefore, t approximately equals, and let's just work out 60 over 200. So what you could actually do if you've got it graphed, and if we made our x value go up to at least 200, one thing that you can do is go shift trace and type in 200. You'll see y is 0.3. If you don't want to do it at the graph on your calculator, you can go 60 over 200 in normal calculator mode and get 0.3. So 0.3 minutes. Now, if you want to get very fancy, then you can actually convert this to seconds. And there are 60 seconds in a minute, so I've got to times it by 60. T is 0.3 times by 60. So 18 seconds. Now, usually we'd use an approximate if I rounded, but I didn't actually round in that case. It is exactly 0.3. Is your answer from F actually reasonable in the real world? So this is getting more at this RC2 performance standard, drawing your conclusions, but then are they reasonable? So with this one, no. Splitting the lawn between 200 people would have lots of issues, including space limitations and the time taken to start up the lawnmowers being a larger the total time due to these issues. 18 seconds is not realistic. Like realistically, you put 18 people on the lawn, they're going to be bumping into each other rather than actually doing the lawn more efficiently. All right, something like that, space limitations, time. You imagine squeezing 200 people onto this lawn. They're not going to fit for one. And then when you're talking about times like 60 minutes, the time taken to start up and put away the lawnmower isn't much. But if you're talking about 18 seconds, that time will actually factor in to a much larger portion and it won't really be 18. All right, so f of 3 for this one. So f of 3, what this means is that you do 2 times 3 plus 4. So you plug in 3 for the x value. you get 10. Find x such that f of x is 16. So f of x is 16, and f of x is 2x plus 4. So 2x plus 4 is 16. So 2x is 12. So x is 6. Wonderful. All right. Now there's a couple of calculator ways you could have solved this one as well that I'll just mention. So this is good to double check your answer. I can enter as a graph 2x plus 4. This is my function. And then we'll just go V window and I'll hit the standard button again to get us back to normal. All right, so there it is. If I go shift trace and then I type 3, I'll see y is 10. So that was my answer from part A. And if I go G solve, so shift F5 across and I hit xcal, I can type a y value. That would be 16. Now, when y is 16, x is 6. That's what we said. Now, if you can't trace something, like if I try and trace 20, for example, it's out of domain. That would just mean that your window would need to be a bit bigger. So you can change these numbers in here, x min and max, along with a y min and y max, to make sure that you've captured everything. All right, solve this set of simultaneous equations algebraically. So I might actually show both methods, and then you can pick whichever one you want to do. So you can choose one method out of these two, don't do both. So elimination, what we'd want to do is get the same number in front of x and y. So if we call this equation 1 and equation 2, I can double the top equation. So I get 4x plus 2y is 6, and that is 2 times equation 1. And then the bottom one's going to stay the same. 4x plus 3y is 5. Then we subtract the two equations from each other. So this is going to be 2 lots of 1 take 2. I'm going to get nothing. 2y take 3y is minus y, and 6 take 5 is 1. Then at this point, you can pretty much times the equations both by minus 1, and you get y equals minus 1. Once we've done that, we can sub it into any equation. Maybe this top one is going to be the simplest. So 2x plus y equals 3. So that's 2x take 1 equals 3, which gives us 2x equals 4. So x is 2. So we get 2 with minus 1 as our answer there. Now, substitution. What we can do is rearrange equation 1 to get y equals 3 take 2x, and then plug this back into equation 2. So that started 4x and 3y gives you 5. Therefore, 4x plus 3 lots of 3 take 2x, because that was the y value, equals 5. This is from 1. All right, if we expand this out, you're going to get 4x plus 9 take 6x equals 5. So that would give you minus 2x if you group those terms together. And we'll go 9 over here, equals 5. So that tells you that minus 2x is 5 take 9, so that's minus 4. So x must be 2. If you do that, then you can pretty much sub it into the top equation there. 2x plus y is 3. Therefore, 2 lots of 2 plus y is 3. So 4 plus y is 3. So y is 3 take 4, or it's minus 1. So that's 2 minus 1. So no matter what way you do it, you can get the right answer. I'll remind you that if the equations are set up like this, there's also a way you can sort of cheese it in your calculator. So you can go to menu, you can go to equation mode. Simultaneous is F1. We're solving for 2 unknowns, x and y. And you make the numbers here look like the numbers on the equation. 2, 1, 3, 4, 3, 5. There we go. So we get the same answer. All right. Next we have the cows question. So Mixie is mixing up a slurry of food. It's got 370 grams of fiber. So how many kilograms of each food type did she use? And this should clue us into what we should call x and y. Let x be the amount of grass used in kilograms. Let y be the amount of Dr. Moo's cow feed used in kilograms. All right, so we should pretty much always let x and y be the thing we're trying to find. So we need two equations. X plus y should be 5 because we're making a 5 kilogram mix of food. And it's got 370 grams of fiber. So that would tell us that 50x plus 110y is 370. Just like that. Call this equation 1 and equation 2. All right, now we can use elimination to solve this, for example. So we could times the top equation by 50. So I get 50x plus 50y is 250. And I get 50x plus 110y is 370. So this is equation 1 times 50 and equation 2. And then we can just subtract the equations from each other. So you get minus 60y is minus 120. Therefore, y is minus 120 over minus 60. So y is 2. And it's good that we got a positive number here, because otherwise we'd be in trouble using a negative amount of Dr. Moo's cow feed. All right, we can work out x from this. So if we know x plus y is 5, that would tell us that x plus 2 is 5. X is 3. So we have used 3 kilograms of grass and 2 kilograms of cow feed. Wonderful. All right, next up we have this part B. Now, I'll pre-warn you, there's not like a standard formulaic way to solve this in 11 methods, but essentially you've just got to problem solve and think about what you might want. So she's trying to make this mixture as cheap as possible while hitting the requirements for fiber and protein. So she'd like to have more grass in the mixture if possible, mainly because the grass is much cheaper than the cow feed. So basically, how much grass can we put in the mixture while still hitting those two limits? Now, the x and y are going to be the same as before. Let's write out these two limits in terms of equations. So something has got to be greater than or equal to 300 grams of fiber. That would be 50x plus 110y. And for the protein, we're going to have at least 200 grams of protein. And that is going to come from this column, 30x plus 80y. Now, I might actually just do it over here. All right, so pretty much we've also got here x plus y is 5 still, because she's making a 5 kilogram mixture. So every time I see a y, I can replace it with 5 take x. So let's do that over here. So we've got 50x plus 110 lots of 5 take x has to be greater than 300. So that if we expand it, I've got 550 take 110x has to be greater than 300. So we can collect like terms on this side. So that would give you minus 60x plus 550 is greater than or equal to 300. Now what I might do is I would want to move the 60x over here so that that was positive. So we're going to get 60x here and maybe move the 300 there to subtract from 550. So you've got to get 250. 250 is greater than or equal to 60x. So that's the requirements for fiber. And then if we sort of work this out, we can. So pretty much if I wanted that to be exactly equal, 250 over 60 is 4.166666. So x has to be at most 4.16 kilograms. And that's the fiber requirement. Now let's do the same thing for the protein requirement. So protein. So that's going to be 30x plus 80 lots of y is 5 take x. Has to be greater than 200. So this is 30x plus 400 take 80x is greater than or equal to 200. Therefore, and we can collect like terms to get minus 50x over here. And then if we do the same thing, so the 50x can come over here and the 200 can subtract, so you get 200 here. Basically, x has to be, if you divide by 50, less than or equal to 200 over 50. Therefore, x has to be less than or equal to 4. So the question is, how much grass can we put in this mixture and still meet our requirements? Well, the fiber requirements tell us we need at most 4.16 kilograms of grass. And then the protein requirements tell us we need at most 4. So this here is the most possible to meet both requirements of that graph. Therefore, 4 kilograms of grass and 1 kilogram of cow feed is needed. I won't lie, that's a tricky question, but it's a really good example of a curveball sort of A-level question, really testing your understanding of this. And if we do try the x is 4, y is 5 method, y is 1 method, we can actually check this. So 30 times 4 is 120, add on 80, we're going to get 200 grams there. 50 times 4 is 200, add on 110, and I'm going to get 310. So we've hit the 300, and we've hit the 200 grams, and it's also going to be as cheap as possible because we're using more grass than cow feed. One follow-up question could be, how much does this cost? And then you would just do, it costs 4 times that plus 1 times that to get the total cost. All right. Next, find the equation of this circle. The center is marked on the picture. So this is going to be x take 1 all squared, y plus 2 squared because it's negative 2 there, and the radius here appears to be 3, and we can double check that because this goes from 1 up to 4, and that's a length of 3. So that's going to be 3 squared. So it's x take 1 squared plus y plus 2 squared is 9. State the domain and range. So what x values can it take? It can take, let's see, minus 2 is the lowest x value and 4 is the highest. So minus 2 is less than x is less than 4. So that is our domain. And our range is going to be from minus 5 up to 1. Minus 5 is less than y is less than 1. Is the circle a function? No. It fails the vertical line test. If I chuck a vertical line there, it will hit the circle twice. Find the equation of the hyperbolic function. So we know all hyperbolic functions look like a over x take b. The asymptote is just the b value. So this is going to be x take 4. And then we need to use the y-intercept. So there is a handy formula for hyperbolic functions. Let's see. There we go. The y-intercept is minus a over b, and you can actually rearrange that to get what you need. So y-int is minus a over b. Therefore, minus a is b times the y-int. Therefore, a is minus b times the y-int. So that's something you can go on a cheat sheet if you want. But essentially, to get our a value, it's going to be minus, the b value is 4, and the y-intercept was minus 0.5. So our a value is actually 2. Therefore, y is 2 over x take 4. Now, once you've worked this out, I'd really encourage you to graph this on your calculator and see if it works. So just clear out some of our old functions there. So let's look at 2 on the top, x take 4 on the bottom. Hopefully we see that same asymptote at 4. And if I go trace at 0, y-intercept should be at minus 0.5. Domain of this function. So the domain should be x can be anything except for 4. And for the range, y can be anything except for 0, because those are the two asymptotes there. All right, question 10. So we got this circle here. We want to find both the x-intercepts of the circle by setting y equal to 0 in the equation. So I've got x take 4 squared plus y squared is 25. Therefore, x take 4 squared plus 0 squared is 25. So we have x take 4 squared is 25. How do I get rid of squaring this bracket? I square root. So I get x take 4 is root 25. Now, I've got to be very careful about this because when you take a square root, as I told you in the hint there, it has to be plus or minus because, well, the answer here is 5, but negative 5 squared would also give you 25. So x has got to be 4 plus or minus 5. So in other words, x is 9 or minus 1. Those are the two x-intercepts. All right, so now we're going to graph our circle. So we're going to put in -1 here, and we're going to put 9 there. And let's just make sure that we've got 1, 2, 3, 4 scales on our axes. Now our circle is going to go through that. It's got a radius of 5, so the center of this circle is at 4, so it's just there, and the radius is 5. So it's actually going to go up to that and down to that, and then this is what our circle will look like. You also should label the circle with the equation. So it's x take 4 squared plus y squared is 25. And marking the x-intercepts you found. So to do that, one of the x-intercepts here will be at -1, 0, and then the other one will be at 9, 0. So that's how you can mark those on there. All right, we've then got a table, and it tells you what the x-intercepts are, and how are the a and r values related. Well, I'm hoping the proof up in part A also clued you in a little bit, but essentially, the circle, x take a squared plus y squared equals r squared, has x-intercepts. So one of them is at a plus r, and the other one's at a take r. So here, for example, 3 and 6 give you 9, but 3 take 6 gives you -3. 10 and 7 down the bottom give you 17, but 10 take 7 gives you 3. So that's how that all works. Test your conjecture with another choice or prove your conjecture formally. Now, I'll let you test it if you want to test it. You just pick different numbers and do the same process as part A. But let's prove this formally. So consider, well, we're going to start by having x take a squared plus y squared is r squared. Therefore, x take a squared plus 0 squared is r squared. So you're setting y equal to 0 there to find the x-intercept. X take a squared is r squared. Therefore, x take a is plus or minus root of r squared. So in other words, that is plus or minus r. Therefore, x is a plus or minus r. So x is a plus r or a take r. And that's what a formal proof of that conjecture could look like. Do try it if you want. But when you're dealing with the Year 11 performance standards, the conjectures only require testing, not necessarily formal proof. So that's why I give you the option to test it. I'd also encourage you to, this one is quite tricky to formally prove, but you might want to think about how you could formally prove that. And as a little tip, think about how the numbers on the outside pair up. Notice everything pairs up to 14 in this case. Interesting. All right. Hopefully you found this useful. And good luck on the real test.